Okay, so this is our 2023 paper 1. Okay, so as always, we have calculus on our paper 1. It was already in the short questions on this paper, okay, but this one just puts it in, it wants you to understand the context of it a little bit more. Okay, so it says, when it rains on land, some of the rain soaks up into the land and the rest of it runs off the land. Okay, the runoff curve number C is the number used when estimating the amount of rain that runs off a particular area of land. C is given by C equals 1000 over S plus 10, where S is a measure of the maximum amount of rain that can soak into the soil. Right, there is a lot of crap in that. Okay, for the time being, I really don't care about what C is or what S is. Okay, later on in the question, I might need to understand that a little bit more. But right now, it just says, find the value of C when S is equal to 15. Okay, so if C, remember, you're always writing your formula out first without anything filled in. Okay, so it's 1000 over 15 plus 10. Now the examiner can see you can sub in. Okay, you can get attempt marks now for subbing in. Okay, you can simplify that further to 1000 over 25, or you can type it straight into your calculator because you don't have any variables left. Okay, so as soon as it's all numbers, you can type it into your calculator and we get the answer is 40. Okay, it says when S increases, does C increase or decrease? Justify your answer using the equation, and then it tells you the equation again. Okay, just increase S. Okay, so we are going to try and work this out a little bit. I'm going to work it out in this justification part and then just come back to what my answer is. Okay, so your justification is the maths that proves it or disproves it. Okay, so or supports it. So let's just look at the justification area first. Okay, it says if S increases, okay, so C is 1000 over S plus 10. Okay, so let's let S be 16 instead of 15. Okay, then we will get C is 1000 over 16 plus 10. Okay, so 1000 over 26 instead of 25. And we get 38.461538. Okay, so the number for C has gone down. It makes sense. If you're dividing something up between a bigger number, then you're going to have less per each of those things. Okay, so if you're dividing the same amount of things up in between 26 people in comparison to dividing it up between 25, okay, 6 people means that everyone's going to get a little bit less. So we have it done with the maths. We are also going to write it out in words so that the examiner really has no reason not to give me full marks here. Okay, so S is in the denominator. Okay. When the denominator is bigger, the full number gets smaller. Okay, that's it. When the denominator increases or gets bigger, okay, I'm going to use the word increases because that's what they use in the question, but it really doesn't matter too much. Okay, so when the denominator increases, the value of the number decreases. So we just saw that, we just worked that out, and then it reminded me of what I already knew. Okay, like something like a third is less than something like a half. Okay, so now that I know, I'm going to go back up here, and in my actual answer, I'm going to write that it decreases. And I have my justification now in terms of my numbers and the equation that they gave me, and in terms of words. Okay, rearrange the equation to write S in terms of C. So the equation was C equals 1000 over s plus 10. So, to rearrange this, okay, the weirdest thing in this is the fact that the denominator is where the variable is, okay? We need to get s on a side by itself, but it's in the denominator. I don't want to work with it when it's in the denominator. So I'm going to try and just get rid of this denominator first. Okay, how will I do that? If I want to get rid of something that's dividing, I multiply. So I'm going to multiply by s plus 10 on both sides. Okay, so I'm going to get s plus 10 times c is equal to 1,000. Okay, now I can see s is up here. Okay, it's going to be a little bit easier for me to isolate. So remember, when we're isolating a variable, we use backwards BIMDAS. So we use SABMIB. Okay, so look at what's in the way of having s on a side by itself. We have a c that is multiplying, and we have other stuff, but the other stuff is inside brackets with the s. Okay, so even though it's an adding, it's something within the brackets. Okay, so that's what I'm going to get rid of after the c that's multiplying. So I'm going to get rid of the c that's multiplying first. How do you get rid of something that's multiplying? We divide. Okay, so divide by c so that we get s plus 10 is equal to 1,000 over c. I didn't need to carry my brackets down now because they were just around the full sum. Okay, so they don't really make a difference now that they're around the full sum. And then lastly, to get rid of the 10 that's adding, I can subtract 10. Okay, so I'm going to get that s is 1,000 over c, take away 10. Okay. The values for c go from 30 to 100 using your answer from this part. So straight away, I'm going to take down my answer from that part. Okay. So it's 1,000 over c, take away 10. Okay, so using that, or otherwise, if you see a different method, you need to find the range of values for s. So what can s go between? Okay, what range does it have? So c goes the whole way from 30 to 100. Okay, so let's let c equal to 30 and see what we get for s. Okay, so s is going to be 1,000 divided by 30 minus 10. Okay, you can type all that into your calculator. 1,000 divided by 30 and then subtract 10 from that answer. Okay, and we get 70 over 3. Okay, so 70 over 3. It doesn't tell me anything about does it want it in a fraction or a decimal or whatever. Okay, so 70 over 30 or 23.33333 recurring. Okay, and let's do it where we let c equal to the other. So that's what c is at its smallest. C can go up the full way to 100. Okay, so let's see what s is if c is 100. So divide it by 100 and then subtract 10 so that we get 0. Okay, so these are my two values for s when c is at its max at 100 and when c is at its lowest, s is 23.3 recurring. Okay, so s goes from something to something. We write the smaller part first. Okay, so it goes from 0 to, and then either 23.3 recurring or 70 over 3. Okay, so part B says, over the course of one day, so 24 hours, the probability that it is raining could be modelled by the following function. Okay, so that's its probability. Okay, so P of T is the probability that it's raining. Okay, so that's what P of T is, the probability that it's raining. T hours, so T is my time of hours. Okay, again, probably might not need that until later on in the question, but let's just read and see. It says, write down the probability that it is raining at the start and the end of the day. So that is, and it actually tells you exactly what you're finding here, so you don't even need to understand the context. It says find the value of P of 0. Okay, so you're subbing in 0 for T and P of 24. Okay, so P of T was, now this is getting a bit messy, so I'll just, okay, so P of T was 0.3 plus 0.02 T. Okay, so they want P of 0. So we are subbing in 0 instead of T. Okay, that's what they showed us. They took away T and they put in 0 in its place. Okay, I'm subbing it in brackets. Okay, and then once I've gotten rid of all my variables, I can type the full thing into my calculator. Okay, P of 0 is 0.3. And then I'm going to do the same thing for P of 24. Okay, so P of T is 0.3 plus 0.02 T. Okay, so now I want P of 24. So I'm getting rid of the T and I'm subbing in 24. So 0.02 times 24. Okay, type that all into your calculator. So 0.3 plus 0.02 times 24. And we get 0.78. Okay, so that's P of 24. Okay. Now it says, find the value of P dash of T, the derivative of T, and explain what the value of P dash of T means in this context. So, up here, we have the probability that it's raining, okay, and we see that it goes up very slightly as the day goes on. Okay, so if this is my graph, okay, this is my time of day, and this is my probability that it's raining. Okay, so the first thing it says is find the derivative. Okay, well, we know how to find a derivative. It doesn't matter what it means. Okay, find the derivative. So P of T is 0.3 plus 0.02 T. Okay, we know what happens in the derivative. If there is no x, or in this case, they've switched out x with t. Okay, so there's no t. Okay, that means that that number is going to disappear in the derivative. And this one has a t and there's no power on the t. So that means that it's just the number in front of that stays. Okay, so it's 0.02 is my derivative, P dash of t. Okay, that's my derivative. And then it says the meaning of P dash of t. So we need to talk about the meaning of a derivative. Okay, the derivative, remember, is the slope. So when we have the slope is 0.02, okay, what does that mean in this context, in the context of this question? Okay, so I'm going to write it down. Okay, the slope is 0.02. Now that's really not in this context. Okay, that really isn't going to get me a lot of marks, if any. But I'm writing it down anyway so that I can help my brain register what it is showing me. Okay, the slope is 0.02. So what is that showing me in terms of the probability of the rain after t hours? Okay, so it's a positive slope. Okay, so the probability that it's raining is increasing. Okay, because it's a positive slope. So the probability that it's raining is increasing. Okay, it's a positive slope. It's going uphill. It's increasing. Okay, and it's increasing by 0.02 for every hour that passes. Okay, so every time it goes up by one value of t, okay, the slope is increasing by 0.02. Okay, so the probability that it's raining is increasing. Not only do we know it's increasing, but it's increasing by 0.02 for every hour that passes. Okay, so go back and reread the question and see is there any other words that you can put in here that they use. Okay, so over the course of one day, so I could say over the course of that day, the probability that it's raining. So the probability that it's raining technically in Waterville, okay, P of T. So for every hour that passes, I might say after the start of the day. Okay, so after the start of the day. Okay, so I'm using those words. I'm not just writing the slope is 0.02. I'm trying to put that into context. What does it mean if a slope is 0.02? Okay, it might start here and then it's very slowly increasing, but not just slowly increasing. I'm saying the exact increase because we know what it is. Okay, at a certain time, the probability that it's raining according to this model is 0.35. Work out the probability that it's raining, exactly 1 hour later according to this model. So, two ways you could do this. Okay, we could find, okay, well, what time is that at? So let 0.35 be the probability and rearrange this to find that time and then sub in the time for the 1 hour later. Or we could see that we've just said that the probability that it's raining is increasing by 0.02 for every hour that passes. Okay, so exactly 1 hour later, it's going up by 0.02. Okay, so at some time, it's 0.35. Okay, and we have just said because we found that the slope is 0.02. Okay, so plus the slope. Okay, so plus 1 times whatever the slope is. So you can write it like this, P dash of t. Okay, or we don't even need to write that. We can literally just see it's 1 hour later and we have just stated that 1 hour later it increases by 0.02. Okay, so that is 0.37. Okay, so the other way we could have done it if you wanted, I just want to make sure that it does not look like it's part of this, okay, is we could have said, okay, so at what time is P of t equal to 0.35? Okay, so we could have rearranged this. So 0.3 plus 0.02 t. Okay, so we would have then minus 0.3 from both sides, so that we got 0.05 is equal to 0.02 t. And then we would have had to divide both sides by the 0.02. So divide both sides by 0.02. Okay, so 0.05 divided by 0.02 is 5/2 or 2.5. Okay, so 2.5 is the time that they were looking at that had a probability of 0.35, which means 1 hour later, okay, the time is 3.5. So we could sub that back in. So we could say, so what is P of t when I'm at 0.3 plus 0.02 times 3.5. Okay, so you can see I've literally just increased the number that's multiplying 0.02 by 1. Okay, initially I was subbing in here 2.5 by the 0.02. Now it's increasing by 1. So I would get 0.37. for p of 3.5. Okay, so if you didn't spot how to use this derivative here, you could have done it out like this and you would have still gotten the same answer. It would have just taken you a little minute longer.